Hey, 350. It's Chris here. One sec. I'm gonna run through a little intro to the fourth lab, which is Gamulator. Um, this fourth lab is very, very, very similar to the LC4 lab from 240. If you did take 240, congrats. It's also going to be a lot of switch statements. Um, if you have not taken 240, um, it shouldn't be too much to pick up. It's a relatively straightforward lab. Um, the main focus of this lab is we're going to introduce a kind of chip, with it we're going to introduce um, a series of ISA instructions you're going to get familiar with. Here's an example of it. Um, all of these ISA instructions you're going to implement, and then you're going to read in a file, um, parse through the ISA instructions, and then emulate what would happen if this chip were to run the ISA instructions. The focus of this lab is getting you familiar with ISA and assembly. Uh, you will, at the end of this lab, be able to run a couple games. So Gamulator is actually, it comes from this chipset 8 emulator that was developed in the 70s or 80s. And the focus of the chipset was you could have different, it was a theoretical chipset that you could have different kinds of game consoles or whatever, and they could all run the same games because they could all emulate the same instruction set. So this lab is basically just making an emulator for that, and it should be fairly straightforward. Since we're doing this remotely and we want to standardize sort of compilers, we want to standardize everything that people can and can't do with code, we're actually going to give out a VM for this. So if you scroll down to in your Gamulator handout, developing your code, I know we're jumping around here. You're going to want to install VirtualBox. Some of you may already have it. And then once you install VirtualBox, which I have right here, you're going to want to click right here to get your Ubuntu image. I've already downloaded it, and we're just going to go ahead and get started making a new VM. So I'm going to name this one, just doesn't really matter, but ESC 350 Lab 4. I'm going to change it to Linux and Ubuntu 64. I think I already... There we go. So it's going to ask how much memory you want. Honestly, anything above 1 gigabyte should be sufficient. You can do it with less if you're running into a situation where you don't think you have enough memory in order to give this VM 1 gigabyte. I would recommend probably running this code on ENIAC and X11 forwarding to your laptop. If you have any questions about that, let me know. But most of you should have probably 4 gigabytes worth of memory in your laptop. I'm just going to go to sort of halfway on my laptop, click Next. I'm going to use the existing virtual hard disk, which is what we installed, this VDI. And I'm just going to click on the VDI. Please remember, when you get started with this lab, download the VDI first. That should be the first thing you do right off the bat, because it's about 5.1 gigabytes, and depending on your internet connection, that might be the main limiting factor as to how long it takes to get through this lab. So we're just going to click Create, click Enter to start this VM, and it's just going to get started. So a couple heads up about this lab. This is a 2-week long lab. We will be, it's all started. Password is 1234. We're very secure. This is a 2-week long lab. It is an individual lab, so you are doing this on your own. We will check and compare code for similarities, but in terms of overall clarifying questions, feel free to post on Piazza, communicate among your peers. Uh, this is only individual because to sort of even out teams, because some teams might be in the same time zone, some teams might be separated by 12 hours. We haven't taught how to use GitHub. We don't want to push a lot of focus on collaboration. The main focus of this is just to see that you're familiar with the concepts. And so this is just going to be individual work. In the past, you should be able to get it done in 2 weeks. In the past, this was a quick 1 week lab for an individual group for groups of 2. So in general, what I recommend doing is when you have this VM open, if you've never worked with a VM before, try to avoid at all costs using the browser in the VM. Unfortunately, the next thing we need to do requires us to use the browser, so I'm going to have to use it regardless. But the next thing I'm going to do is I'm going to download the starter code. I could have a folder, a shared folder, download it locally, and then move it over to this VM, but I'm just going to go ahead, copy this address, and then do tiny URL because I can't, as you can see, I can't copy over between the VM and my actual machine, so I'm just going to use tiny URL and do tinyurl.com / however you would, that's okay. So from here, we're just going to pop open the VM and then download our starter code. I'm going to download all. It's going to zip it all up, and then I'll unzip it, and you can get started on this as if it is a. So all of this, these are all C files, so you can get started with it. You should be able to compile it right off the bat. There is a README explaining how to compile it. You could use Vim to edit your code, Notepad. There should be a version of Eclipse installed on this VM, if I remember correctly. You might have to sudo that, but yeah, whatever you want, use it to edit. In the end, we will request if you make any changes to the compilation instructions. Maybe you want to use something. You shouldn't need to change the compilation instructions, but in case this isn't sufficient for you, just let us know, and then package that up into README. Click OK to this. The document should be relatively straightforward in terms of what steps you need to follow to complete this lab. In general, I would recommend just read through the document. If you have any questions, let us know. We'll post sort of a version of a recitation that goes through a little bit more about this lab on Monday, and then on Tuesday we'll host, during my regular recitation time, we'll host a Q&A on Google Meetup, and Google Meetup will be, I'll post the link around Tuesday at 6 p.m. on Piazza, and you can come, you can ask a question, anything clarifying for this lab. I highly recommend just read through the document, give it a second, give it a glance over, and it should hopefully be relatively straightforward. There's only one major checkoff for this lab, and that's that you send in your code at the very end. We'll try and run it, and we will use a series of games and just figure out how many games can we run that you're correct on. So we'll have one game that only tests a certain amount of the ALU instructions, then we'll have a game that tests even more, and then a game that tests even more. So just let us know if you have any questions. Best of luck.